Hello, I'm Tom Walski from Bentley Systems, and I'm here today in my role as a member of the Water Distribution System Analysis Subcommittee of EWRI. And we're here today to do another one of our interviews. We have Chun-Hou Orr as our guest today. We're in Kingston, Ontario. It's the 25th of July, 2018. And we're going to talk to Dr. Orr now. And okay, you started off your career in electrical engineering and controls. You want to tell us how you got into that and how you made that transition from electrical engineering and controls into water systems?
Yes, and I'm my background is the electronic engineer, and my PhD is in control engineering, system engineering, and it's quite natural at the time when I finished my PhD, and thinking about to do something more than that. We were looking at power system, gas system, etc. And then, I saw this, advert advertised by Brian Kovac, and looking for some people working on similar things in something like that way. So, but that, the field he picked, and interestingly, because his feeling was basically at the time the power system, a special power system for the electrical engineers, and relatively well saturated. Many things have been done already, and many people working in the field. Something parallel to it, gas, and somehow alien to us, and the water, one possibility, and that there were not that many works, at the time available. You see, the open field and actually more complex in some ways, and over the power system. So he thought that would be a good, opportunity to go into it, and he got a research grant, and then he was moving from Sheffield down to Leicester. And I was, moving up from London to Leicester. We met halfway, and we started together, something like that way. And so we built, then we, being control engineers, okay, we were looking into the control in the things on the water systems. The first things came to our mind basically, and that was basically optimized pump scheduling. So that was the first things we were working on, and we were working on we were lucky to basically be able to contact, the Anglian water system on bulk supply systems, and relatively simple, and relatively easy to incorporate the hydraulics, etc., into the optimizer directly, and also we built that, and the optimizer, and we highlighted to actually using the computer graphics, etc., interactive, and in those days, and 1980, and there was something, and the Anglian Water they were quite interested. Okay, and been helping them to save the pumping cost up to 20%. We actually invited the operators to try out using that experience what to do, and then saving consistently 15 to 20% better than their experience. That was great, at the time. But as we moved on to something, a more complex system, we were not able to incorporate every single hydraulics, into that. Then we will start looking into the analyzer, the simulator, and we pick up, the simulator, and when we started going into that, things becoming more involved. So we say, that way, and then you are involving more than just, the pump scheduling. We're talking about things like the storage, and the tanks, pipings, networks, etc. Those kind of problems. You open up the field. So, but then, we were able to get, the Yorkshire interest in that, and they use it, to design their, local town, and they were mighty excited. And then, there was a time, we came together, and we basically, and Brian's idea was today, let's run, the national conference to present our works together, what had been done before. And that was with the Durham University, UMIST, Cambridge University, and so we came together to run this, the first, and the CCWI, today's CCWI, and the very first one, something like that way. And from then, immediately we got the, interest from Severn Trent. So from then onwards, we were in getting more and more involved into the water industry. From then onwards, virtually we were moving over from electrical disciplines over to the water, and the discipline, looking into the water, system problems, and trying to solve them, and etc., and trying to deal with their problems. And since then, basically, all my time, all my career, becoming in for the water industry.
Yeah, I remember the first time I heard of you guys was talking with Uri Shamir about control systems and water. And Uri said, those guys, Kulbik and Orr, they're doing some really good work. So that was my first introduction to you guys from Uri. How different is water then? How much did you have to study fluid mechanics, or did you just pick it up along the way, or did you take a course in hydraulics?
No, none at all. Basically, actually, I had zero, understanding about water systems. To be fair, to say that, I had no clue about what, Hazen Williams, that kind of thing, C values, what was that, etc. Well, I simply say, use Ohm's law. I was talking to, and over the last couple of days, I just seeing them at Ohm's law, the different kind of representation, instead of linear, becoming non-linear, etc. And that's relatively easy to move over from that. But that's different to the different kind of complexity. So something like, but no, it wasn't easy, difficult to move over. Storage, reservoir tanks, capacitors, you see, so easy. Something like that way from that point of view, okay. But obviously, and as you move along, you see that more and more you had to build up the understanding. What are the unique problems in the water field? We were lucky that we started the work from the early beginning. That we were working with the industry, with the engineers. So they are, along the way, they have been educating us as well. So we built up the knowledge as we moved along, and we were still building the I'm still building the knowledge as in and the 10 years later, 20 years later, to understand and what actually the problems are, you see, in the water industry, you see. And so over time, from the time, the years I spent in England to the time I spent in the United States.
Okay. How was it, you guys were researchers. How was it on the business side? Did you guys also have to be like accountants and lawyers and such when you're doing contracts with these water companies?
It was fun, and actually, we were basically, the researchers, and Brian and me, and we have been just between the two of us, for a number of years, and even when we were running the second one, the CCWI, and there were still the two of us, about it. But we were, and being researcher, of course, the primary objective, one thing is that you need to apply for funding, and from somewhere, at the time, when we started the work, the funding was from the Science Engineering Research Council in the UK. And there was research funding. That was easy, okay. But later on, you see, but that they only sponsor you limited amount, and the time frame, that extent. And since from the beginning, we were able to talk to, work with, the water, and the industry, water field. So naturally, the question would you be willing to sponsor our works? And after the conference, those two conferences, and the first one already have the interest from the Severn Trent. After the second one, and when the more divisions from Severn Trent to come in, and they were sponsoring very heavily for our works. And they were basically, and because the simulator will basically pick up directly from the dynamic EPS type, the simulation, comparing with what they had at the time, and so only steady state. And something, they were happy to be able to use, we present them graphs, etc., those things already, differences, etc. And from the early days, providing with pump cost, etc., evaluation, because we did the optimization. That was easy for us. And they actually, and the interesting thing is, basically is that, the engineer, and without telling us, and she was sitting in my office, going through all the bills from the authority, and comparing the cost, something, our computation and the bills, and they're very comparable. They were so happy, Okay, they're building up that degree of confidence. And hydraulically, and in terms of, and we did the calibration, and the module for that, even though we never officially released it. Okay, and and that, we were using that, we would be able to tell them, pinpoint to them that, that particular valve, you see, no way it was open. Okay, to get the matching, the measurements and the simulated results. And then they without telling us, they took the chief operators to go to the field, to open up the valve to see what was happening. The valve was closed, and that really, that convinced that side as well that there was a value for that. So and 720 decided that, yes, that was something useful to them. So and they say, and we were basically saying, and we would like to take on your simulator. That was a time basically not only sponsoring our works, but at the same time think and to purchase our software for that, for us that the whole authority to use. And that was the first basically time we were going into and basically the commercial end. Okay, but since they worked virtually and up to that moment, and largely sponsored by the UK Science and Engineering Research Council. So and the copyright ownership belonged to the British Technology Group. So they owned it, okay? So they had to negotiate the contractual issues with them. The money paid to them, etc., that kind of things. And then from then onwards, basically, and we were also entering with some trend onto the real-time control, those things. And so getting more and more involved, and the real-time simulation, real-time control, that kind of things. And it was interesting to say is that one thing was, at the time, and that was mid-1980s, and also we got the Bob Clark's water quality module. We actually plug it in with our simulator. We got it running, up and running. We could have easily had the water quality and with our simulator available already in mid-1980s, for the water authority, water industry to use, but that, unfortunately, not being the water engineer, not and something like that, we did not have the understanding, and equally those people were more interested in terms of the hydraulic analysis rather than the water quality. So nobody mentioned anything about water quality, the importance to us. Okay, so it was my decision thing, and I was too busy to make our simulator Genus to be fully commercial. That I said I did not have the luxury to incorporate it. So let's leave it out. And for that, you guys, you're great to come in to do the real water quality works and be able to incorporate into EPAnet, etc. for today's usage.
Yeah, now software has all these clever names, like Windows and KY Pipe and all. What were the names of some of your products? Do you guys sit around thinking of names of software? Or you just say this is just our simulator, use it.
No, and
fancy names.
And I'm in parallel to many people using today, and in the wrapping, and over and above, EPAnet, to become different, and packages available today, and for the water industry, we didn't really start from scratch, and that wasn't our objective anyway. We were on control side. We took Walski, okay, and we took it, and Walski was basically fully dynamic already, and of course we equally like the EPAnet, we made a lot of changes, you see, and enhance it, expand it, debug it, etc. For our and the applications. So we took it, and then of course we had to change the name. Okay, and Brian's idea was just use network analysis and simulation. Since I put on a lot of and interactive features, and we say I put on the I, it sounds awful, INAS, something like that way. Since it's kind of graphical, not fully graphical, but in the 1980s that was basically satisfactory. So why not put the other word G in front, becoming Genus, and that and the 720 was the first one to take it on, And later on, the Thames Water also came in to use it, and they used it actually to redesign the London Ring mains, and completely based on that. You see, of course, we had to make certain enhancements for that particular 3 meter and 3.5 meters diameter tunnels, and that kind of end purpose. And then later on, the Yorkshire also came in to use it, and becoming more and more people coming in. We got plenty of and the plans and put and the ideas to extend it, and unfortunately and the Brian decided to take early retirement.
Okay.
So I took a leave to go to the other side of the pond.
Okay. Now you've been more of a programmer really than an engineer most of your career, haven't you? I mean, you probably started in Fortran and now are using other languages. How have you seen programming evolve over these years?
I mean, depending on basically and the which field you are in, you see, basically, in case you're talking about the whole, today's, the software, and many many layers about it. And I'm basically in the early days, then that was easy, basically, not much, then they don't go to multi-layer things, and a little bit, packaging about it, and that was easy to one single language, and the single package, something like that way. That was based, yes, that was, based on Fortran.
Doing Fortran,
yeah.
You're doing C++.
Yes, and that, from then onwards, we can see, you see, and towards the end of 1980s, I could see, the different language coming in. Okay, especially you want to use, these enhanced features. Fortran wasn't there. Okay, nowhere to basically that. So I had to move, up to different kind of language. There was a time I moved on to C-based type of languages, something like that way, and been adequate for time, and since then been responsible for mostly on this kind of and the lower layer kernel side, numerical side type of and developments. So and that kind of the C-based language fairly adequate for that. So so I don't need to basically to the extent to talking about the UI level, that kind of thing, that you had to look at more modern developments. So that relatively more and stable. You see, so it's still ongoing that way, and that's I can foresee that in a foreseeable future, they are likely to stay the same way. You see, so and that it's not really urgent need that you had to adapt to change the different kind of environment, different kind of languages, etc.
You've been more the guy working on the engines as opposed to user interface.
I did all. And but that and that's and it's not easy to find anybody to be able to have the ability, the understanding to do that kind of the modules. That means you need many and the experience background. You need to know engineering, you see, and you had to have the engineering judgment, be able to understand what was required in engineering sense. Okay, which is easy said than done, and I think and I'm sure basically you have come across that many people these days it's very hard to find what is engineering judgment, and something like that way you had to know about, be able to develop the more complex applied mathematics based and type of technologies, optimization and numerical things, and also numerical analysis, is to be able to understand what might be 0.0001. What kind of difference, comparing in the 0.01, that kind of things, and also be able to get into put the things down together, develop the things, easy, that kind of thing you can find and the mathematicians and the engineers, PhDs, to come in to handle those things easy too. But equally, you need to, in case you want to package things together, you see, you also need to understand about what is required on computing, and the software packaging side too. Okay, you're talking about things like software engineering. You're talking about planning, designing. You see, you're talking about, more importantly, maintenance. You see, and you have to think about structural and organization planning for your software, and frameworks, etc. The modules, and then you think about long-term maintenance. You think about basically be able to be able to expand. Be able to self-maintaining, that kind of level, and if we challenging to find anybody to be able to do so. And probably I got more experience than most, at least in what I have experienced so far. That is why I'm still responsible for that part of the work.
Okay, how about optimization? You started, nowadays most people are using evolutionary algorithms.
Yeah.
You probably started with dynamic programming in your early days?
Absolutely. There's no talking about possibly. You tried to run the simulator, say, more than a few times about that, forget about it using genetic algorithm, and then that was totally impossible case, So, and the things basically more at the time, and what we did, the first one was based on a dynamic programming. You see, and that was very good, and we of course we enhanced a lot for that particular purpose to make the system run, and that works very effectively, accurately, and something like that way, giving us, unbeatable results. You see, you can try it. You see, and we also offer the features for people to try. You see, and we always beat them. Something like that way, we are quite comfortable about that, and then of course we try non-linear programming type of activities. We also try that, and so on and so forth. We cut the two activities, and in terms of optimization as well as the developing the simulator. You see, they were going in parallel. Okay, so something like that way, and because at the end of the day. You see, and the more successful module we had was the simulator. That one brought in a lot more funding than the optimizer. You see, I'm sure basically many in case you look at industry today, whatever you do, whatever you're talking about so far, and everybody is talking about you somehow you are using a simulator. That's why EPA is becoming so regularly mentioned everywhere. It's something like that, virtually, in every single presentation. It's something like that. Where you need that, analyzer to be able to evaluate your performance. You see what you want to do.
Okay, so then you left us off on one side of the pond, and you're now on the other side of the pond. So how did you get involved with software? You had a gap there between your time developed as a researcher and time working for Innovise. How did you fill in that gap?
Yeah, when I left, in England, then I thought that they say I'm working out of the water industry, and because the Brian's retirement was really unexpected, big shock to me. We were such a partners, He was like a fatherly figure to me too, and such a big shock, really, and found it very, difficult to take. So I was thinking about to move on, and like Brian what he was saying at the time, same thing that he was talking about to do a new research work, okay, and so on. I was still young, young enough, and so to try something differently, about it. And so I got the invitation to join a small consulting company over there, and to start something differently. And but at the same time, I'm still working, and I was quite fortunate in my career that I was still working within the team from Lisbon, the National Laboratory of Civil Engineering, and two particular persons I would like to mention is Elena Allegra and Sergio Coelho, and working with them together. And that so I was still staying together with the Waterfield and about it, so I wasn't totally out of that. And somehow basically I think it was Alena and running into Paul in one of the conferences, and he mentioned to Paul Boulos, and that it was that coming to a time Paul was thinking about to form this company MW Soft. And that I think Elena mentioned that to Paul that I was in Southern California too, you see, and then so Paul contacted me, and so he brought me in and work on, and there wasn't, and he did not have anybody there at the time to work on the numerical side, so he brought me in, say you take care of that, something like that way, and so I joined the Paul's team from the very beginning. And so still with the same company, and 22 years later.
22 years.
Yeah, 22 years with, working with Paul, and for 21 years, something like that. And so I think probably the longest history, and with him about that, and very closely with his works too. It's not that somehow you see in the area that he has less experience of. It's directly overlapping with his own, and area. So somehow I was able to work with him for 21 years, and and also fortunate really, and in a way, see, and in many ways, basically, really fortunate to also be able to work with him. He's got a very sharp mind. Okay, something like that way, and he be able to make certain judgments that that was basically very sharp, and that way that it was fortunate to be able to work with some people with understanding, and with that kind of sharp judgment and decisions and directing about exactly what we should be doing, etc. So.
Did you have a lot of autonomy as far as directing where
No, I think to say something about that the time I was with Paul, you see, for the previous 21 years, and in spite of many and the opinions about something that no, I basically really effectively, and he just lay out, you see, and the general things and the targets, basically objectives, what you want, and I would like to get to. Okay, and I think virtually he leaving me the free hand, and he never sat next to me somehow bugging me about somehow how I was going to do it. You see something, and so leaving me the free hand to be able to for me to get from here. From the beginning to delivery.
So you weren't micromanaging. He wasn't sitting here going.
No. He was. And he totally and give me the complete free hand to do so. And he also trusted me for that. You see one thing, and to the extent and many years later, you see, and that he trusted me to take on Ipe Swim. So from water, also taking on the wastewater and stormwater side as well. Okay, so again, so you can see from control engineer, water industry, into basically into the wastewater and stormwater side. Okay.
Yeah, swim is even more complex.
Oh yeah, far more so. So he left me completely free to handle it.
So now that you've conquered all of these things, usually one of our last questions is, where do you see the industry going? Where are we going to be 10 years from now?
And really, that's an open question about exactly which way it was going to go. And in my time, it's basically, and in many ways, everything, and in terms of hydraulic engine, engine in the development side, basically, not that fundamentally different from what what you were and and the presenting yesterday about the early days development to today's relatively just kind of slowly evolving, something like that way, and many people are happy with and the existing and the software, etc. And I mean not many people who bother to change the EP net completely for that, something like that, and but that I think basically water quality, you see, and instead of the major advance during the early 1990s, virtually basically, and not much in the development. There's no major advances in that particular field, and the thing I'm also feeling and major, and I mean to my personal experience about it, there's a major danger in that particular. And when you see, especially these days, this generation users, as I know that basically they are relying on the computer generated results for their things, and that I know basically how good it is on the water quality side. To me, basically, it's more art than science. Okay, and as like the Vanessa was talking yesterday on her presentation, there's still many after 20 years of her works, still many unknowns. Okay, and I would like to say one thing is that, and I was also very fortunate and to run into my other half, and she is the district engineer for the water and for Los Angeles County, and she highlighted to me a lot of these issues on the water quality side, and something I did not know I wasn't aware of. So he highlighted to me a lot of those issues, and that the things basically he showed me things like basically safety, you see, and liability, that kind of that kind of things, too, and that in case you are using the artistic water quality of today's standard, okay, and then thinking about it, you use it, rely, believing it to it, and blindly taking the results blindly as it is. Or generally, that is, and say 0.8, and the milligram milliliter, and for your chlorine residuals, and you take it something like that, or 0.2, something too low, something like that way. You say and safety or something like that. You just directly that way. How and use judgment to say, and for your, and the various safety or your consumers, etc. How good it is, and something in case you use it to that extent. You see, and what might be the impact? That's an open question about it. I think, and as you know, basically, and the people, I've seen many examples. The water quality time step, guys, and majority users still using it randomly. Okay, you use the different water quality time step. Good luck you. Okay, and then you use the result directly for your, you see, and you see making, decisions for the consumers. Again, good luck, to the consumers too. You see, I think, somehow people should address those issues for the sake of those users using them for your safety, measures. Okay, that's something I would like to see, and about in that, somehow the improvement on that, and like for example, the water age, water going in and out of tanks, something like that, different time steps, and how good it is, something like that way, and many areas, and I hope somebody, and it'd be nice, in case US EPA would be able to, to take the lead. Because really at the end of the day, and you put a US EPA there, the utilities would take it on, without arguing, and at the same time, I can see basically things like, and basically the info, we are and running into the information age, okay. And unlike the good old days, the time I mentioned about to you earlier, that and talking about the doing the calibration of the system, they will only have a few flow meters, okay, and a few flow loggers and put it in for a certain time period. These days, basically, the information readily available, you see, and continuous basis, smart meters, etc. What can we make use of them for? How can you make use that kind of thing go into your analysis, planning, design, etc., operations, etc.? How can you make use of your result compared with the things? Still probably, in the early stage for anybody to get really into it. So I think probably chances are, no doubt, out there people would try to do it. I hope something might happen to be able to enhance basically combining the two together, the analytical field and also the information, and in the available, so to bring it, to a better, and state too, than what we are today.
Great. Okay, Dr. Orr, we appreciate your taking part in the interviews, and you're going to be one of the folks we have on the website with all of our other interviews with some of the senior people in the industry. So thank you very much for sharing your experience with us.
Thank you for having me.